Hello, 405. Welcome to Lab 3, Prediction of VO2 Max from Submaximal Exercise Tests. For today's lab, the objectives are to study the adaptations of cardiovascular function with aerobic training. And we're going to be predicting VO2 max from field tests. And the experiments, those field tests are going to be the YMCA step test and the 1.5 mile Cooper test. So let's talk about cardiorespiratory fitness, abbreviated CRF, is related to the ability to perform large muscle, dynamic, moderate to vigorous intensity exercise for a prolonged period of time. And key words there are performing dynamic, moderate intensity exercise, performing large muscle groups, right? So an example could be like taking a jog outside, even very moderate intensity jogging or cycling, anything that requires us to use large muscle groups and that we can maintain for prolonged periods of time. That's going to be mainly our cardiorespiratory training, how we're going to be able to improve our respiratory system, our cardiovascular fitness, and our musculoskeletal fitness, more specifically our endurance, right? Our muscular endurance. So cardiorespiratory fitness is considered a health-related component of physical fitness. So we know from studies that low levels of cardiorespiratory fitness are we're a higher increased risk of premature death from all causes, right? Specifically cardiovascular diseases. We also know that with an increase in cardiorespiratory fitness, right, us improving our overall cardiorespiratory fitness, we can see a reduction in death from all causes. And also, we know that with high levels of cardiorespiratory fitness, there's also higher levels of habitual physical activity, right? We're less sedentary, we're more physically active, which in turn is associated with many other health benefits. So cardiorespiratory fitness and training is overall good, right? Now let's talk about the concept of maximal oxygen uptake. That's VO2 max, the maximal volume of oxygen consumed per unit time. You probably learned this before in 301. We know that VO2 max is the single best measure of cardiorespiratory fitness. And it's typically expressed clinically as relative and absolute terms. In relative terms, VO2 max is taking into account the body mass of your client. So as you can see, relative VO2 max is milliliters per kg per minute. That's the maximum volume of oxygen consumed per unit time according to the body mass of my client, as opposed to the absolute terms, which is just milliliters per minute, right? It's just an absolute value of VO2 max. So we can express it in two ways, right? Relative and absolute. This allows for comparisons between and among individuals with different body weights, right? So we might have two clients that are the same gender, the same age, but different body weights, right? Usually someone that is a little bit higher on their body weight, they're just, they're taller, they're bigger, they're just overall more mass. They're usually gonna have a better like maximal like capacity for uh, their cardiovascular function, respiratory function. So they're usually going to have a higher VO2 max compared to someone that might be smaller, right? It's just in general, their cardiorespiratory system, the respiratory system is going to be smaller. And, that's just how it goes with comparing between and among individuals with different body weights. VO2 max is the product of the maximal cardiac output, that is liters of blood per minute. right? And we know that cardiac output is the amount of blood pumped by each ventricle per minute. And cardiac output, as you can see here on the bottom right, is a function of heart rate and stroke volume. So cardiac output, CO, equals heart rate times stroke volume. Heart rate, we know that's the number of ventricle contractions per minute, right? Beats per minute. And the stroke volume is the amount of blood ejected from each ventricle contraction. So that's going to be heart rate times stroke volume equals cardiac output. So VO2 max is the product of the maximal CO, cardiac output, and arterial venous oxygen difference. The arterial venous oxygen difference, it's the blood that has circulated through your cardiorespiratory system, cardiovascular system is returning back to the heart. That's essentially what it is, right? So there is significant variation in VO2 max across populations and fitness levels, and that is mainly because of differences in Q, that's cardiac output, CO. And what does that mean? Um, across there's going to be variation of VO2 max across populations and fitness levels because cardiac output, we can improve that through the stroke volume, right? If we do our due diligence and we follow through our cardiorespiratory training, us improving our cardiovascular fitness, we're going to be able to improve stroke volume. The amount of blood that we can send to our working muscles so we can continue performing that type of exercise. We cannot do much about heart rate, right? That is just beats per minute, our heart beats per minute. We can increase stroke volume with training, right? And become more efficient at pumping blood to our working muscles. So that's a way that we can increase cardiac output. So VO2 max is closely related to the functional capacity of the heart, right? So that's why VO2 max is the single best measure of cardiorespiratory fitness because it's so closely related to the functional capacity of the heart. So here are the cardiovascular training adaptations. This figure, you've probably seen it before in 301. This is laying out the adaptations of cardiovascular function with aerobic training or cardio training, right? So we can follow through the diagram over here and we can see that, that improving that stroke volume, increasing a stroke volume through doing our cardiovascular training, that will increase cardiac output, how much blood is being pumped, right, to the body. That in turn is going to increase the effectiveness of cardiac output distribution, right? There's optimization of peripheral flow. There's an increased blood flow to active muscle and thus more oxygen to the working muscle, right? So pro tip, biggest takeaway from this slide is that with aerobic training, with cardio training, we improve our oxygen delivery, that oxygen utilization for our working muscles to use for energy, right? To continue the intensity of that exercise. So keyword here, highlighted in blue, oxygen delivery. But these are all the adaptations that are happening from aerobic training. Now let's talk about measurements of VO2 max. We have direct and indirect. Direct measurements are using maximal exercise tests where we are exerting ourselves to maximal effort, right? And you've probably heard of this one before as well. It's the Bruce protocol that is performed on the treadmill, like on the figure up here. You are running at incremental changes in the intensity, right? The resistance on the inclination on the treadmill uh, increases, and there's multiple stages. And um, the purpose of the Bruce protocol is that you are exercising at those increasing workloads until there is no further increase in the VO2, right? That's how we can um, directly measure VO2 max. It's using an open circuit spirometry, and we can also do indirect calorimetry. Indirect measurements of VO2 max are using submaximal exercise tests, like the ones that we'll perform for lab, like the YMCA protocol on um, on the bike. That's one that we used to do before in 405, actually, when you are performing a graded exercise test at a submaximal heart rate, and you are recording exercise heart rate and exercise blood pressure. And through this protocol, you can estimate VO2 max, right? But it's at a submaximal intensity. And the ones that we're going to perform for lab are going to be the step test and the 1.5 mile Cooper test. Indirect tests of VO2 max are usually terminated by a predetermined endpoint. And the two most common are percentage of heart rate max. For example, we determine that we want to stop the test if our client reaches 85% of the heart rate max. If they reach that, we stop, and then we move on to the recovery period. Or we can do RPE if they reach a 16 to 17 range, like they perceive that the exercise is a 16, like very hard, then you stop the test. Now for maximal versus submaximal exercise testing, how do I know which one to perform? Main reason depends on the risk level of the individual, right? And also the availability to appropriate equipment and personnel. Um, if and the most common are going to be submaximal tests to determine heart rate response to a submaximal work rate and use those results to predict VO2 max. These are the safer ways to predict VO2 max that do not require the individual to exert themselves to volitional fatigue, right, to their absolute max. And you minimize risk of injury or uh, similar things like that. It might not be feasible for individuals who may require emergency equipment, right? You probably don't want to do this if your client has a cardiovascular disease or some sort that might potentially aggravate the their condition, right? So we have to be very careful about that. Now, for prescribing exercise intensity for cardiorespiratory fitness, we're going to get a lot more practice throughout the semester, but as an introduction to prescribe intensity of exercise, we follow the FITT principle, and it's laid out right here. The FITT principle is presented as frequency, how many days per week you want to train, the intensity, percentage of heart rate reserve or percentage of heart rate max or VO2 max, time, duration per session, and type, mode of physical activity. So FIT stands for frequency, intensity, time, and type. Any other additional recommendations are, for example, quantifying the volume of a training. That's the product of the frequency, the exercise intensity, and the duration. And also, other recommendations are the implementation of progressive overload, right? Over time, you will improve your cardiorespiratory fitness. So you have to make adjustments every so often, every 3 weeks, 4 weeks, so that you or your client is progressively improving their cardiorespiratory fitness. So this is table 5.1 from your ACSM 11th edition guidelines. the aerobic exercise recommendations. As you can see, it follows the FITT principle, frequency, intensity, time, and type. So the ACSM recommends for frequency of cardio training to at least train 3 times per week. And for most adults, you can spread this exercise into different sessions, like anywhere from 3 to 5 days per week, right? So it's not too taxing at the very beginning, and it's a little bit more doable the long term. Intensity, that's if you want to be at a moderate intensity exercise, 40% to 59% of the heart rate reserve, and or vigorous intensity, that's 60 to 89% of the heart rate reserve, is recommended for most healthy adults. I do want to highlight that this table is for overall healthy adults. We will learn in other labs about recommendations for individuals who have, for example, cardiovascular disease or hypertension or asthma, right? So those recommendations are going to be modified based on that specific population. But for now, you guys can focus on this table. Time, for most adults, they should accumulate 30 to 60 minutes per day of moderate intensity exercise, or they can do 20 to 60 minutes of vigorous intensity exercise, or a combination of both, right? Whichever is most appropriate at the moment, depending on the fitness level of your client and what their fitness or their specific goal is. And type. Any aerobic exercise performed in a continuous or intermittent manner that involves major muscle groups is recommended for most adults. All right, so for the in-lab practice, we're going to go over the SEP test and the 1.5 mile test. You're going to be working in lab partners, and you're going to assist each other. You're going to record basic data, heart rate at rest, then post-exercise, and you're going to record that on your data sheets. Please use the following tables to rate your client, rate your partners. This table is table 3.11, the YMCA 3-minute step test. So based on the data that you gather from your lab partner, you're going to look at this table, if they're women or men, and then selecting the rating from there. For the 1.5 mile test, you're going to need these equations. So again, if they're women or men, you're going to select the appropriate equation. You're going to need the time of the 1.5 mile test, the body mass of your client, and then you just input it on the formula and solve, and you will get the predicted VO2 max. These are the tables that you're going to need to score the 1.5 mile test. So as you can see, there's different tests here in the columns, but you're going to look at 1.5 mile run time. And then from there, you're going to go down the columns, the rows. You're going to look at VO2 max. You're going to score there, and then you're going to select the rating. If it's good, excellent, and the percentage, like 85, 90%. And that's it. For the lab manual, you're gonna solve the results section and answer in complete sentences the discussion questions. Thank you, 405, and happy studying.